Hi friends, myself Abhijit. This is my first video on YouTube, so please like it and subscribe my video channel. Actually, this channel is about electronics and all concept related to electronics. This video is about concept of voltage and current and direction of current. So what is voltage and current? In present time, we can't imagine our life without electricity and electronics. Just think what would have been happen if there were no fans, tube lights, TVs, mobiles in our life. Yes, definitely. It would have been very much struggleful of life. So by thanking electricity, we will go in details and see actually what electricity means. The whole concept of electronics and electricity is dependent on the word voltage and current. So let's see what is voltage and what is current. First, we will see the definition part of voltage and current. Then we will go in actual explanation of voltage and current. So by definition, what voltage and current means? Voltage is also called as an electromotive force, is a potential difference in a charge between 2 points in an electric field. Its unit is volt and symbol is V. If we consider this as an example, this picture as an example, this is a battery, voltage source, so-called voltage source. So the voltage is a potential difference in charge between 2 points in an electric field. If we consider these 2 points, if we consider this as a positive, this as a negative, then the potential energy difference between these 2 points means this point is also having some potential energy in it, and this point of a voltage source is also having some potential energy in it. So the difference between these 2 points, these two potential energies, is a voltage. This was a definition of voltage. Now let's see the current definition. Current is a flow of a charge in a conductor or semiconductor. Its unit is ampere, its symbol is I. Flow of charge in a conductor means what? The voltage source which have energy in it makes the electrons, that is charges, to move in this conductor. The energy in this voltage source forces the electron inside this conductor to flow. That results in current flow. Voltage or current can be direct or alternating. A direct voltage or current maintains the same polarity at all time in an all time. In an alternating voltage and current, the polarity reverses its direction periodically. But basically, in this video lecture, we will only concentrate on the DC part. I will make another video for the AC fundamentals. Let's focus first into the DC and let's know how the voltage and current works. In direct voltage or current, polarity doesn't reverse. Polarity remains the same throughout the time. Means if this terminal is positive and this terminal is negative, then it will remain same for the whole time. But it's not the case in this AC circuit. If this terminal is positive in if this terminal is positive in AC circuit, and if this terminal is negative, after a half cycle of period, this terminal will be negative and this terminal will be positive. That's why it is called as an alternating current. Means the polarity reverse at every alternating cycle. It was just a definition. Now let's move on to the actual explanation of what is voltage and what is current. Let's see voltage first. But before going into the detail of a voltage, we must know what is the energy, because the whole concept of voltage is dependent upon the word energy. I will prove how it is dependent upon the energy, but let's see first what is energy. Energy is needed to do some work and its unit is joule. In concept of a voltage, energy is needed to do some work, means energy is needed to move a charges from one point to the other point. Some energy is required to move the charge, that is electron, inside the conductor from one point to the other point. So that energy is provided by the voltage. Voltage is also a kind of energy which when released result in moving of electrons, and this moving of electrons result in current flow. Here here it is an example. I have shown this picture. Here this person is voltage and this person is an electron. This voltage is kicking this electron into the particular direction. Here amps is written, means I will explain what is amp in the concept of current, but this person is electron. If we consider this pipe, if we consider this pipe as a conductor and this person as a voltage and this person as an electron, then from this diagram it conveys that voltage is pushing the electron inside this conductor. So this is a concept of voltage. Voltage is giving energy to move this electron into in particular direction. Now we saw what is energy. Now let's see what is voltage. Voltage is expressed as joules per second. Joules is energy. How much energy is flowing per second, that is voltage. It is also called as a potential difference in a charge between 2 points in an electric field. I have told you that this battery, which is voltage, is nothing but the difference in the energy of this point and this point. Means this point is also having some energy and this point is also having some energy, and the difference between these two energies is nothing but a voltage. So what is a potential energy? The potential energy is an energy that is stored in an object, which when release energy some work is done. The stored energy inside the battery will force the electron to move inside the conductor. This is what a concept of voltage. We will see the calculation part of voltage, how to calculate a battery's voltage, battery's current, power consumption. We will calculate in few minutes. So that was a voltage. Now let's see what is a current. Current, it is expressed as a coulomb per second. I will tell you what is coulomb and how this ampere is calculated. But current is a coulomb per second. Unit of a current is ampere. Ampere means number of electrons flowing through a certain point in a second. It is termed as ampere. Before going into the details of a current and amperes, first let's see what is a charge, because the concept of this charge plays an important role in explanation of current. Suppose we have these two charges which are opposite charges. If this charge is positive, this charge is negative, then we know that opposite charge attract each other. That means they will try to come near to each other. And we know that similar charges repels each other, means they will try to go away from each other. This concept is used in a conductor to explain current. Consider an atom with a positive charge in a nucleus and surrounded by an electron. This image shows an example of only single electron for simplicity. Considering this one electron and just one atom, actually in conductor there are many atoms and many electrons in it, but for simplicity we will only consider one atom with one electron. So if one electron is made to come near this electron, then they will repel each other and this electron will move or jump from here to here. Then again these two electrons will repel each other and this electron will jump from here to next atom, and the chain continues. This concept where this electron is moving or jumping from one atom to another atom and going into the particular direction is called as a flow of electron. This flow of electron results into the current. The journey continues, which causes electron to move forward, and thus electron flow through a conductor. Now we saw that what is current, but how to configure it, means what is an ampere, how that unit is decided. A current is said to be of 1 ampere when 6.24 into 10 raised to 18 electrons flow through a certain point in 1 second. If we consider this point, then if 6.24 into 10 raised to 18 electrons are flowing through this point in 1 second, then it can be said that 1 ampere of current is flowing through it. But this number 6.24 into 10 raised to 18 is so complicated to use in a calculations. So scientists came up with a word called coulomb. Here coulomb is used to express ampere. Coulomb is configured in such a way that 1 coulomb is made equal to 6.24 into 10 raised to 18 electrons. Means this term 6.24 into 10 raised to 18 is given name as 1 coulomb. So we can say 1 ampere is equal to 1 coulomb flowing through a certain point in 1 second. So how to represent and calculate voltage and current? As I have told you, voltage is joule per second. It is denoted by joules per second. That means we can say it is 1 volt when 1 joule of energy is flowing per ampere, that is per coulomb. That is, if a supply is 1 volt and if load, considering this example, if supply voltage is of 1 volt and if this load is drawing 1 ampere through it, so considering this example, if this is a load, then it is said to be 1 volt when 1 joule of energy is used to flow a current of 1 ampere through it. Then only it is called as a 1 volt. So taking another example, considering this second example, let this voltage be same 1 volt and let this load draws 1.2 ampere through it. So how can we calculate a power? We know the formula for power. Power is nothing but voltage into current, right? So if 1 volt is supplied and load is drawing 1.2 ampere, then power will be 1 joule per coulomb. This is a term of a voltage, and 1.2 coulomb per second. This is a current. So power means voltage into current. So solving this, coulombs get cancelled, so it will be 1.2 joules per second. That is a power. We know that power is expressed in terms of watt. That watt is equal to joules per second. So it is said to be 1.2 watt when 1.2 joules of energy is delivered. So greater the energy, greater is the voltage. How? So we can say in terms of powering the load, 1 joule of energy will power a load for 1 second. That what watts convey, that what power conveys, it's joule per second. So 1 joule of energy can power a load for 1 second. 2 joule of energy will power a load for 2 seconds, and so on. So From above explanation, suppose we consider this example. Suppose if a battery is of 9 volt, that means for every coulomb, that is for every ampere that flows through a battery, 9 volt is supplied to the load. Means what? If this lamp, if we consider this as a bulb which is drawing 1 ampere, then 9 volt is supplied for 1 second. If we consider this lamp is drawing half ampere, so this 9 volt can be supplied for 2 seconds. This is a concept of energy and load. Now let's see the direction of current. What is the direction of current? I will ask you one question. You tell me, means you decide first what must be right. This diagram is right or this diagram is right. Okay, it's a bit confusing, na? I have told you that negative charges repel, means if this terminal of a battery is negative, then electron will try to repel, try to go away from this point, and this terminal is positive, so it will try to attract these electrons toward it, as electrons is negatively charged. So this positive terminal will try to attract this electron, and this negative terminal will push this electron away from it. So current will flow in this direction, from negative to positive. Remember what I am saying, current direction means right way of a current direction is from negative terminal to the positive terminal. Then why I have shown this diagram, then why I have shown you this diagram which says that current is going from positive to the negative. Actually, this concept of current flowing from positive terminal to the negative terminal is called as a conventional current. Actually, this concept is wrong. Why this concept is wrong? Because this direction was just an assumption. At that time, when this conventional current was discovered by Benjamin Franklin, at that time there were no discoveries of electrons and protons, so it was very difficult to say in which direction actually that current flows. So scientists assumed that current might be flowing from positive terminal to the negative terminal. This is the reason why in many textbooks, reference books, and many of the books we have learned that current, we have seen actually that current direction is shown from positive terminal to the negative terminal. But when the concept is wrong, how can that formulas be right? Actually, if we see in technical details of it, actually that formulas are also wrong. But why we are using it then? Many engineers are using it to solve big problems, to configure big circuits. How that formulas are working? Actually, many of the scientists implemented that calculations, implemented that formulas on many of the circuits, and it seems to work well. The responses that they got from that simulations, the responses that they got from that calculations, and the output was exact. There was no error in it. This is the reason why we are using that formula still now. There might be a different reason for it, there might be a different reason for that formula to work. It can be that many of the circuits are dependent upon the magnitude of the current, not on the direction of the current. So the formulas that we are using can be implemented. If you are an engineer, or you if you are a student, then you can use this concept of conventional current to solve mathematical equations, mathematical formulas. But when it comes to explain someone how actually current works, how actually electron flows, then the technique, then this first diagrams technique, that current flowing from negative terminal to the positive terminal, it is a right way. This is a right way to express the direction of a current. This direction of a current was discovered by J.J. Thomson. This is a right way and this is a wrong way. So please, when it comes in the explanation part, don't explain anybody in this form that current flows from positive terminal to the negative terminal. It is bit confusing that, because we are learning that current is flowing from negative terminal to the positive terminal, but in books and in formulas it is shown that current is flowing from positive terminal to the negative terminal. It's more much time it is debatable topic in some students. So hope your concept are clear now about voltage, current and the direction of current. These are people. This is Benjamin Franklin. This is J.J. Thomson. Benjamin Franklin. In Benjamin Franklin's time, there were no batteries and no knowledge of existence of electron. He was one of the founding father of United States. He discovered the technique of conventional current, which is actually wrong, but in terms of formula it works well. And the technique that was right was discovered by J.J. Thomson. He was a Cavendish professor of experimental physics at Cambridge University and the director of its Cavendish laboratory. Discovery of electron and the concept of electron flow direction in a circuit. It was discovered by J.J. Thomson in 1897. That is after 150 years after the conventional current was used. That means we were using the concept of conventional current for 150 years, and J.J. Thomson brought end to that concept. So by thanking Benjamin Franklin sir and J.J. Thomson sir, we will end this video. In next video we will see about the concept of AC fundamentals, that how AC circuit works, how AC voltage and current works. So friends, if you really liked my video, then please like it and subscribe to my YouTube channel. Actually this is my first video that I am making on YouTube, so please like it and subscribe my YouTube channel, because if you don't like my videos, it will not boost me to make new videos in future. And finally I will stop making videos if I'm not getting that much of likes, because it will be a waste of time for me. So if you really like my video, then please like and subscribe.